All right, now we're continuing with the section 8.1 material, and what we're talking about now are some patterns that we saw back in chapter 2. We saw patterns of a perfect square trinomial created when we squared a binomial. And so what we see in our chapter this time is we're going to have a trinomial, and it's going to have two perfect squares in it and a middle term that's the roots of each of the squares times 2. Now whatever this sign is right here is going to be the sign that we'll see in the middle of the binomial. And whatever the sign is what we're going to see. So this one here would be a minus in the middle here. So what we're going to want to do, because it's faster, much faster as a matter of fact, we're going to want to recognize this pattern. We're going to want to recognize that we see two perfect squares. Those two perfect squares, by the way, will have the same sign. Usually that will be plus, but not always. So usually, sometimes it might be both minus, but usually they'll be plus. And then we want to get the roots of those because we'll need them. And that's where, in the second step, we'll need them. We'll need to check that this middle term is twice the root times the root. And if it is, then we're going to write it as each of the roots in a binomial squared, and whatever the middle sign is, we'll put in the middle here. Plus if the middle sign of the trinomial is a plus, and minus if it's a minus. So let's practice that. So we have a trinomial here. I see a square, I'll get its root. I see a square here, I'll get its root. And then here I want to see is twice each of the roots, and the roots are 3 and x. Are those the middle term? If yes, which it is, then I'm going to get a binomial squared, root of the first term, root of the last term, and whatever this is goes in the middle. And that's it. That's factoring this thing. All right, now let's try it again. Next we have a perfect square here, so we'll get its root, and a perfect square here, we'll get its root, and then here in the middle we have twice, and then the root, and the root, and we'll see 2 times 2 is 4 times 3 is 12. Yep, that matches. So we'll write a binomial squared, root of the first term, 2x, root of the last term, 3, and whatever the middle sign is goes in the middle. And that's all we have to do. And what you noticed here was, hey, you could even factor when the leading coefficient wasn't 1. So that's kind of cool, because now we've got a way of factoring one special trinomial anyway when the leading coefficient isn't 1. All right, now we're going to throw in the combination of a GCF. So you see, our leading coefficient isn't 1. There's not a GCF all the way across that'll take out the leading coefficient, but there is a GCF for sure because they're all even. So let's take out a 2. So if I take out a 2, 2 goes into 32 16 times, so 16x squared, and then 2 will go into 80 40 times, and that's 40x, and then 2 will go into 50 25 times. And now what we see, oh yeah, there's a perfect square there, that's 4. And you can write down the x if you want to, or you don't have to, because it hangs around, right? We know that. And then the 25, we can write the 5 here, and then in the middle we want to check this, 2 times the 4x times the 5, does that give us our middle term? And 2 times 4 is 8, and 8 times 5 is 40, sure enough. And so now we'll write, don't forget the GCF, and then we get prepared for the binomial squared, so the root of the first term, 4x, the root of the last term, 5, and whatever this middle sign is goes in between them. And that's it. That's factoring, and we've combined both our factoring strategies, that from 8.2, and this new perfect square trinomial factoring strategy. Now, it's really helpful for you guys to know your perfect squares. So again, here's a list of perfect squares. I recommend that you know all of those. This is 1 through 13, or 1 through 15. There actually should be 14 in here, which is 196. So let's write that one down as well. So 196 as well, and 225, and then remember 25 squared, which is 625 as well. So those are the ones that I recommend that you memorize, and that way you'll be able to recognize perfect square trinomials. All right, we'll pick up with a new pattern in the next video.